question number 10 in the exercise. The same diagram for example 6.3. Here in exercise question is sin alpha plus beta equal to sin alpha cos beta plus cos alpha sin beta. Example that is cos alpha beta. First we can see sin alpha plus beta. As like the previous question, consider the basic things. We want to refer the previous question. Let A cap equal to OA and B cap equal to OB be the two unit vectors, and they are making the angles alpha and beta with the positive x-axis. So OA makes an angle alpha and OB makes an angle alpha. Draw the perpendicular to x-axis, it is AL. And once again use the right angle property and find out what is OL and what is OA. We are getting it is cos alpha, sin alpha. Similarly, we are getting cos beta, sin beta, but it is fourth quadrant. We can mark it as cos beta minus sin beta. So obviously we are getting A cap equal to cos alpha I plus sin alpha j, B cap equal to cos beta I minus sin beta j. Okay. So here the angle between OA and OB is combine both alpha plus beta. Okay. So already told you sin means use cross product, cos means use dot product. So obviously take B cross A, don't A cross B means we have to put minus k. So magnitude of B, magnitude of A, sin, what is the angle? Alpha plus beta, and the unit, the normal to both I and j is k. Okay. So unit vectors, therefore the magnitude is 1. Sin alpha plus beta into k, take it as 1. So now by the determinant method, first row I, j, k, second row components of b, cos beta minus sin beta 0, cos alpha, sin alpha 0. With respect to the third one, cos sin alpha, cos beta minus into minus plus, first cross minus second cross. So cos alpha sin beta into k. So obviously I told you two vectors are equal, therefore their magnitudes are equal. So equate their magnitude, don't cancel k vector. So we are getting sin alpha plus beta equal to sin alpha cos beta plus cos alpha sin beta. Okay. So the same diagram, same basic construction, we can use it for example 6.3. The same diagram and the basic construction same for all the 4 questions. We are getting A cap and B cap. So our aim is to prove cos alpha plus beta equal to cos alpha sin beta, cos alpha cos beta minus sin alpha sin beta. So wait it here. The same diagram and the same thing, but cos means use dot product. So A vector dot B vector by definition magnitude of A, magnitude of B into cos theta. Here the angle is alpha plus beta, unit vectors magnitude is 1, cos alpha plus beta, take it as 1. A dot B ordinary dot product. So cos alpha I plus sin alpha j dot cos beta I minus sin beta j. So cos alpha cos beta minus sin alpha sin beta. So from 1 and 2 both are equal. Cos alpha plus beta equal to cos alpha cos beta minus sin alpha sin beta. So we are getting the result. Once again repeating the important concept. Listen my dear student. Alpha plus beta means take the first one in the first quadrant, second one in the fourth quadrant. Okay. The same basic construction, same triangle. The angle between is alpha plus beta. So what is A cap and what is B cap? Cos means use dot product. Okay, cos alpha plus beta means use dot product. Sin means use cross product. In the cross product also put B cross A, don't forget. Again, alpha minus beta means take both on the first quadrant. Okay. Cos means dot product, sin means cross product. For sin, B cross A. Suppose if you are putting A cross B means minus K vector. That's all. Okay, student, now the remaining 4 problems is regarding with the physics application oriented. It is involving moment and work done concept. Question number 11. A particle acted on by a constant forces 8i plus 2j minus 6k and 6i plus 2j minus 2k is displaced from the point 1, 2, 3 to the point 5, 4, 1. What is the total work done? Okay. So first to find out the resultant force. So the resultant force F vector equal to sum of the two. Just simple, are the two. Okay. So 14i 4j minus 8k. Okay. So let me take the 2 points as let A and B be the points. So OA vector equal to, write these points in terms of component vectors, I plus 2j plus 3k. Similarly, OB vector equal to 5i plus 4j plus k. Okay. So now the displacement D vector equal to, okay, final minus initial, OB minus OA. So 5 minus 1, 4i, 4 minus 2, 2j, and 1 minus 3 minus 2k. So we get the resultant force F vector and the displacement D vector. Now the work done W equal to F vector dot D vector, the dot product of the two. 14 into 4, I dot I is 1, 4 plus 4 into 2 and minus into minus plus 8 into 2. Okay. So it is, I think, 56. Okay. And plus 8 plus 16. So what is the answer? So 64, 70, 80 units. So work done is 80 units. Exercise 6.1, question number 12. Look at the question. Forces of magnitudes 5 root 2 and 10 root 2 units acting in the directions of 3i plus 4j plus 5k and 10i plus 6j minus 8k respectively act on a particle displaced from the point with position vector 4i minus 3j minus 2k to the point with the position vector 6i plus j minus 3k. Then find out the work done of the forces. So listen here, the resultant force F vector equal to, it is the combination of addition of two forces, combination of two forces. The first force is having this magnitude and the direction of this vector. Therefore, the first force is F1 is this magnitude into the vector and its magnitude. Okay. So sum of the two forces, first force can be considered as F1 and the second force may be considered as F2. So resultant force is F1 plus F2. So F1 having this magnitude and this direction. So F1 vector is nothing but the magnitude into the vector by its magnitude. So root of 9 plus 16 plus 25 plus the second F2 is this magnitude and this direction. So 10 root 2 into 10i plus 6j minus 8k by its magnitude, root of 100 plus 36 plus 64. So 5 root 2 3i plus 4j plus 5k. Okay, again 50, root 50 is 5 root 2, 10 root 2, so 10i plus 6j minus 8k, Again it is 200, that is 10 root 2. So cancel. So here also cancel the sum of two forces. So 10 plus 3, 13i. Okay. So 10j and minus 3k. Okay. Again displacement. So take it as OA vector and this is OB vector. So OB minus OA, final minus initial. So 6 minus 4, 2i. Again 1 minus or minus plus 4j. Okay. Minus 3 plus 2 minus k. So we are getting the displacement d vector. So now the work done W equal to F vector dot d vector, the dot product of that's 2. So 13 into 2, 26, okay, plus 40 and plus 3. So 69 units. That is the answer. Into displacement F vector dot d vector. Now they are asking torque. So find the magnitude and torque of the force 3i plus 4j minus 5k about the point with the position vector 2i minus 3j plus 4k acting through the point with the position vector 4i plus 2j minus 3k. So obviously the force F vector is directly given. Okay. So here it is about the point. Okay. So about the point with the position vector and this is through the point with the position vector. Okay. So here torque T vector, okay, or moment is given by R cross F. So F vector directly given. So R vector, remember, so it is through minus about, R at minus about, remember like a formula, through minus about. Okay. So it is through the point with the position vector, it is about the point. So 4 minus 2, 2i. Okay. Then 2 minus of minus plus 5j. Okay. Minus 3 minus 4j minus 7k. So we are getting the R vector. So remember through minus about, it is about and through. Okay. Now the torque T vector, T cap equal to R cross F. So using determinant method, I, J, K, component of R, don't change it, R cross F, not F cross R. So R or components 2, 5, minus 7, 3, 4, minus 5. Okay. So now expand this determinant. So delete the first row and first column. So minus 25. Okay. So plus 28 into I. Okay. So minus next one. So delete the row and column. Minus 10, minus 10, minus 21, minus 10, and that is plus 21 into j. Okay. Plus delete that row and the third column. So 8 minus 15 into k. Okay, T vector equal to, okay, 3i 11 minus 7k. The first subdivision is they are asking magnitude. So magnitude means modulus of T vector, that is nothing but square root of x square plus y square plus z square. So 9 plus 121 plus 49. So 179. Okay. So they are asking this is direction cosines. Dc is nothing but x by r comma y by r comma z by r. Okay. So 3 by root 179 minus 11 by root 179, 7 minus 7 by root of that value. So this is the required answer. Exercise 6.1, the last problem, 14th question. Find the target of the resultant of three forces minus 3i plus 6j minus 3k, 4i minus 10j plus 12k and 4i plus 7j at the point with the position vector 8i minus 6j minus 4k and about the point with the position vector 18i plus 3j minus 9k. So here the resultant of the three forces, consider this as F1, F2, F3. Okay. So F1 plus F2 plus F3, sum of the three forces. So what we are getting? So 8 minus 3, 5i and 13 minus 10, 3j and what is that? Plus 9k. And already told you r vector means it is through minus about or at minus about. Okay. So through it is at, so 8i minus 6j minus 4k minus about 18i plus 3j minus 9k. Okay. So minus 10i minus 6 minus 3 minus 9j minus 4 plus 9, 5k. Now we have the formula target T vector is nothing but r vector cross f vector. Again determine method. First row the component vectors I, j, k. Second row the components of r. Minus 10, minus 9, 5. Second f. 5, 3, 9. So first row, first column deleted. Minus 81 minus 15, okay, into I minus, delete the row and column, minus 90, okay, minus 25 into j plus, delete the row and column, minus 30 plus 45 into k. So the torque or moment is minus 96i 115 minus into minus plus 115j plus 15k. That is the answer for the last question.